Hello, this is Wajahat Nazeer, and I have just recorded a Hindi version, Hindi or Urdu you can say, of normal distribution. Now again, that lecture was around 40 minutes long, but this time I will not take more than 20 minutes and I will try to convey the complete concept of normal distribution. I have watched different videos, and when I'm looking at those videos, they are very difficult to understand. So we will try to make it very easy, and believe me, normal distribution is easy. So how it is easy? Let me prove it. First of all, try to understand what is probability. We are not going into detail of probability, just a small definition that probability is the happening of an event. Probability calculate the chances of an event. That's all. The range of probability is from 0 to 1. 0 means no and 1 means yes. When you are sure about an event, the probability of that event will be 1. If you are unsure about an event, if you know that this event will never happen, then the probability of that event will be treated as 0. 1 can also be transformed into 100%. You can say between 0 to 1 or between 0 to 100%. This is probability. Now, second point to understand about normal distribution. We are moving towards normal distribution, but step by step. Probability. What is probability distribution? So now you need to understand what is probability distribution. For that, you have to understand what is outcome of an event, and the probability of that event, because together they are known as probability distribution. Okay, that's why you have to understand what is the outcome of an event and what is the probability of an event. Let's take an example of dice. We are taking an example of dice. So we are throwing a dice one time. So now let's observe that what are the different possible outcomes and their probabilities. Together they will be treated as probability distribution. X is a random variable. Either when you throw a dice, either 1 will arrive, 2 will arrive, 3, 4, 5, 6. Only 1, 2, 3, 4, 5, 6. Only 6 options are there. So definitely it can be either one of them. So what is the probability? What is the probability of coming 1? The probability of coming 1 is 1 over 6. The probability of coming 2 will be, sometimes people say that it's 2 over 6. No, it will be 1 over 6. 3, 1 over 6, 4, 1 over 6, 5, 1 over 6, and 6 will also be 1 over 6. The total probabilities in any experiment when it is done on the basis of mutually exclusive event. These all are mutually exclusive events. They cannot happen together. Either 1 will arrive, 2 will arrive, 3 will arrive. So probabilities of all these events will equals to 1. So these are the outcome. This is the probability of those outcome. Together we say that this is the distribution of this experiment. So this is known as probability distribution. The probabilities are distributed among the outcomes. The probabilities are distributed among the happening of an event. So this is the probability distribution. Now quickly move to the next point. Now probability distribution will be divided into discrete random variable and continuous random variable. So now we are saying that the probability distribution will be further divided on the basis of discrete random variables and continuous variables. Discrete random variable are those variables, those are easily countable. Those are easily countable, or we can say that there is no value between the two numbers. For example, let's take an example of number of boys in a classroom. So either the number of boys in a classroom will be 29, or either the number of boys in a classroom will be 30, but there will be no value between 29 or 30. You will never heard that the number of boys in a classroom are 29.3. What that 0.3 means, that a boy is a very small one, you will count him as 0.3, so that will never be the case. On the other hand, continuous random variable will be a variable in which we will talk about the measurement, and the random variable x can take any value on that scale. For example, we are talking about height, weight, temperature. So when it comes to be a variable which can be based, which is based on some sort of measurement, then we are talking about continuous random variable. Height, weight, temperature is the best example, because let's talk about again about a classroom in which the height of boys is, you can say 5.7 inches, you can say 6.7 inches, you can say 6.1 inches. So any scale, it can be in decimal, it can be in fraction. So we are talking about that variable whose probability, which can take any, the random variable x can take any value on the measurable scale. Now in discrete random variable, we have three types of probability distribution. One is binomial, another one is Poisson, third one is hypergeometric. Although this is not for our concern, but we are making the base. We are making the base, because to build a building without making a base is useless. That's why I'm explaining what is probability, what is probability distribution. Then the probability distribution is divided into discrete and continuous random variable. And in this continuous random variable, again, we have three types of probability distribution. The first one is normal probability distribution. Normal distribution is there. Exponential is there. So now come directly straight to normal distribution, and now we have to explain what is normal distribution. Clear? Yeah. 8 minutes have been passed. Now we have to look into the properties of normal distribution. Number one, we will talk about around 6 to 7 properties, and then we will discuss one of the most important characteristics of normal distribution, the main property, which is the basis of all the points. So number one, this will always be like a bell-shaped curve. Whenever you will draw the graph of a normally distributed data, you will always find that it will be a bell-shaped curve. And no need to think about the, you can say what we say, that how you are drawing it. You are using a pen, pencil, paper, No need of measurements. Simply draw a bell-shaped curve to prove that this is a normally distributed data. That's the first property of this. Yep. Second, no skewness. Let me draw. This curve has no skewness. Now the point is, what is the skewness? When you will say that this data has skewness, that will be like, for example, that will be like this. This is positively skewed. So if a data is positively skewed, that will not be treated as normally distributed curve. That will not come under normal distribution. So no skewness is the condition for normal probability distribution. Or this is positively skewed, you can draw like this. This will be negatively skewed curve. So this is positively skewed, this is negatively skewed, no skewness. This is the condition for we put cross on negative and positive skewness. We will only take no skewness, the bell-shaped curve, as the property, as the identification for normal distribution. Okay. Third point I am mentioning here, the mean, median and mod are equal. The mean, median, mod are equal, and they will almost in the center of the data. The mean define the balance point, median define the middlemost value, and mod will define the highest frequency. The peak of that graph will be depend on the value of mode. But in our case, in normal distribution, mean, median, mod all will be same. Clear? This is the third point. The fourth point is also very interesting. The fourth point is also very interesting. For example, this is the mean. Let's suppose it is 377. 377 is the mean. You can take standard deviation. Any standard deviation, let's suppose 2.5. 2.5 is the standard deviation of any data. So what we say that the 50% of the observation are greater than 377 and 50% are less than 377. Clear? 5. The area under normal curve. You will always read this point. Area under normal curve is equals to 1 or 100%. The area under normal curve is 100%, means the data will cover the 100% data into it. That means it. That the area under normal curve is equals to 1 or 100%. It simply means that a normally distributed curve will explain about data or will absorb the 100% values of that data. Clear? So area under normal curve, area under curve will be 100%. Clear? Next point. Normal distribution will always be symmetrical. 3, 4, 5 and 6. 6th point will always be symmetrical. It will always be symmetrical. Symmetrical means whenever you draw a line in between, so both the shapes will almost be equal, or they will cover on each other and you will not find any difference. Whenever you put a line in between, then the points on the left hand side and on the right hand side are almost equal. And I give always the example of a human body. So don't think that this eye is big and this is small. No. Whenever you dissect a human being from the center, so you will almost find that the right part will almost be equals to the left part of the body. So the normal distribution will always be symmetrical. This will always be symmetrical. Now the main point, now one of the main point or the most important point is that a normally distributed data will be completely is completely defined by its mean and sigma. This is the mean, this is the standard deviation. That if you have information of a data that this is the mean and this is the standard deviation of this data, then on the basis of only this two pieces, only two parameters will give you the 100% information about the data, and you can comment on the data as you have the whole information, as you have the real observations of the data. So just on the basis of mean and standard deviation, and that you know that this is a normally distributed data, you can comment that you have all the observations. You will be as much informative, as much information you have as someone has all the information regarding the data. So what does it mean? It means there is some significance either in mean or either in standard deviation. So the main point in a normally distributed data is that the significance lies, that on which basis we are commenting, we are explaining each and everything about the data. When we don't have the values, we don't have the data, but we have only two pieces of information. We have mean and standard deviation. So what is the logic? What is the importance? What we have? What sort of magic we have found? So that is the significance of a standard deviation. What is the significance of a standard deviation? Now the 7 points are complete. Now we are talking about the significance of standard deviation, which is known as the empirical, rule about standard deviation of normally distributed data. Any data which is normally distributed, you can find out this image in which I have mentioned the empirical rule, which is 68, 95 and 99.7%. What does it mean? This is 68%, this is 95% and this is the 99.7%. What this empirical rule is telling you about? It is saying that the 68% of the data, any data which is normally distributed, and we know about the mean and standard deviation sigma, so we can say that the 68% data will be lie in between mean plus minus 1 standard deviation. 95% of the data will lie between plus minus 2 standard deviation. And we can say that mean plus minus 3 standard deviation will give you information about 99.7% of the data. Now we are jumping, now we are moving into an example which will give us the best possible explanation. And this lecture is mainly dedicated to one of my students living in Japan, who told me that, sir, kindly record a video so that I can watch it again and again. So I'm taking a real example from his course. This video is equally beneficial for OA level, GCSE, MBA, Bcom, statistics, anywhere you can apply it in MBA, because definitely normal distribution will not change from time to time or place to place. This is not a variable. Yeah, normal distribution will remain fixed, and the inventor has presented this around in 17th century. Yep. So now take an example. We are talking about a sample. The total number of observations are 300 bottles. We are talking about what I'm writing. I'm writing a question. We are talking about 300 bottles in which the mean of those soft drink is 377 ml. That the average bottle which we are finding the mean is 377 ml. The standard deviation sigma is around 1.5 ml. Now on the basis of only this two information, even if the n is not given, don't worry about n. Just on the basis of mean and standard deviation, we can play with the data. We can talk about the data. We can give important facts and figures about the data. So now how? Let's draw a graph. For example, we are saying this is the bell shaped. Now I'm drawing, for example, this is -1 sigma and this is +1 sigma. I'm trying to explain that what will be the 68%, how 68% of the bottles, 68% of the bottles, for example, from these 300 multiply by 68%, take 68% of 300 multiplied by 68 divided by 100, this will be 204. So now we are talking about 204 bottles. We are going to calculate one standard deviation. That what will be the condition of those 200 bottles. And we don't have the data, but we have an empirical rule which says that 68% of the population, 68% of the data of a normally distributed data will lies between one standard deviation, which means 377 plus minus 1.5. So this will become 377 plus 1.5 will be 377 plus 1.5 will be 378.5 ml, and 377 minus 1.5 will be 375.5 ml. So now we can say that this is what? This is 68%. This is 68%. 68% of the bottles are in between 375 to 378.5 ml. Clear? 378.5 ml is the maximum side. 375.5 is the minimum side. So these 204 bottles are at least, they have the value of 375.5 ml per bottle, or the maximum value is 378.5. So now we want to know that how many bottles. Now I'm making a question. This is same. I'm writing a question that how many bottles are, let me write down the question. How many bottles are filled with more than 380 ml. How many bottles are filled with more than 380 ml? What is the probability? What is the proportion? What is the percentage? What is the probability? What is the percentage? What is the proportion? All the words can be used. Proportion, probability, or percentage. Mainly we use the word proportion or the percentage. That what is the proportion of bottles which is greater than 380 ml? What is the percentage? Even probability is not the wrong word. Frankly speaking, probability is not the wrong word, but I don't want to use the word of probability. I am using the word proportion. I am using the word percentage. That what is the percentage of bottles those are filled more than 380 ml? So what we do? Again we have either 377 ml, 1.5 ml. So now, for example, where this 380 lies? Where this 380 lies? So the 380 will be 377 plus 2 sigma. What is the value of mean plus 2 sigma? So mean plus 2 sigma, sigma is 1.5, 2 into 1.5, 377 plus 2.5 will be 3, and this will become 380 ml. So where you are finding 2 sigma has the value of 380 ml. What empirical rule is telling you about? Empirical rule is telling you about that at least, what it is telling you, that 95% of the bottles, 95% of the bottle lies between 2 standard deviation. That 380, what do we mean? What will be the value of minus 2 standard deviation? Let me find out the value of minus 2 standard deviation. 377 minus 2 multiplied by 1.5 will give you 374 ml. So 95% of the bottle lies between 374 to 380 ml. Now we want to know the bottles those are greater than the 380 ml. Now look at this graph where cumulative frequencies are given. So what is the value? Look at the graph. Look at the graph below and find out the value of 2 standard deviation has a value of 97.7%. What does it mean? That from 0 to 97.7%, the value is 2 sigma, 380 ml. Bottles are equals to 97.7%. 97.7% bottles are filled with 97% bottles are filled between 0 to 380 ml. 97.7% bottles are filled between 0 to, from this point to this point, 380 ml. Now we are interested that what is the percentage? How many bottles are filled more than 380? So how this will be done? 100 minus 97.7. 100 minus 97.7. This will be 2.3%. We have n which is 300. Take 2.3% of those 300 bottles, because we are mainly interested in the bottles. 300 into 2.3 divided by 100 will give you 6.9. Around 7 bottles are still there. Those are filled with soft drink greater than 380 ml. So this is the importance of normally distributed data, that if you understand this thing, which is given below. You don't need any table. You just need an empirical rule and the use of this graph. Believe me, you will understand the concept of normal distribution and you can solve any question. So in normal distribution, you don't need any table. Normal distribution is different. T distribution is different. Standard normal distribution is different. So this is all about normal probability distribution, which is different from T distribution, which is different from standard normal distribution. So what I'm doing, the last thing I'm writing, normal distribution is different and standard normal distribution is another thing. Although standard normal distribution is a part of normal distribution or the extension of normal distribution. We will not say the part. This is not the part. Standard normal distribution is the extension of the concept of normal distribution. That's all from my side. I hope you have enjoyed the lecture. Still, you can post comments and I will love to answer them. Thank you. Thanks for watching. Take care. You can also subscribe my video or you can like, even you can dislike. But before disliking my video, must record one video which you think which is better than mine. Thank you. Take care.